Hi, fellow math teachers. My name is John Frensley, and I wanted to tell you about a math-based game that I came up with. And this game is called Laserblast. And so think of it like Battleship, except the students are not going to be using coordinates to attack each other. They're going to be using y equals mx plus b lines. So I want you to imagine that we're going to have a red player and a blue player, and the red and blue player should not be able to see each other's grids. Now, you're going to get to see both teams' grids, but I want you to imagine that these two students may be sitting opposite a table each other or with some kind of divider between each other, but they need to be near enough to communicate to each other, right? So the setup of the game is this, is that red is going to put three bases at three sets of coordinates on the left half plane. Now, this particular game only goes from -5 to 5, -5 to 5, and the X and the Y. You can make it as big as you want. I found that playing it with my students, 10 to -10 it's enough. Okay, it's just enough. So I actually am going to randomly choose where the bases are using a calculator. So -2, 2, we're going to call that base A. And then -2, -4, this is all chosen randomly by a calculator, base B. And then -1, 3 is going to be base C, right? Now, blue is doing the same thing at the same time. So let's say blue is 5, -4. Okay, that's his base A. And then 4, +5, 4, +5. So that's his base B. And then 4, -5 is his base C. All right, does that make some sense there? Okay, so now that's the game set up. The key is that the students shouldn't tell each other where each other's bases are. That's a secret, and here's why. Because now the gameplay commences, and what each student's going to do is they're going to shoot the other guy with y equals mx plus b lines. Now, I believe that every student should be playing all the time, so I don't do take turns. Red and blue are both formulating their lasers at the same time. So red might come up with something like this. How about y equals, I don't know, 1/2 x plus 3. That's the line he's going to shoot. In the meantime, blue is going to say, okay, well, and they communicate the lines to each other at the same time. So red might be ready to say, okay, I'm ready. And blue's like, okay, hold on, give me a second here, right? Okay, so blue might say something like, okay, well, how about I'm going to do, I don't know, -1/2 x, okay, -3. So then, okay, blue says, okay, I'm ready. Red says, I'm ready. So now red is going to say, okay, y equals 1/2 x plus 3. And blue will say, okay, mine. They're going to basically tell each other at the same time. So it's not this turn, that turn, this turn, that turn. They're both playing at the same time. Y equals -1/2 x minus 3. So why are they coming up with these lines? Because here's the rules. You're trying to hit the other guy's bases, right? So then red's going to say, okay, well, here's the line that I just shot, 1/2 x plus 3. So over 1 up, 1/2 x plus 3. So here's my first line right here. And then I am going to say what blue's line was, -1/2 x minus 3. So then that's going to be -1/2 x minus 3, like that. Okay, does that make some sense, right? I have better grids that I could do this on possibly, right? Okay, so this should have gone really through here and through here and off like that. And then through there and through there. If I wasn't nervous and making a video, then I would be more careful than that, right? Okay, then blue is going to do the same thing. Blue's going to do the same thing. So what are they doing? They're shooting the lines at each other, but here's the rule. Are you listening to this really important rule? The lines have to come from one of their bases. So they can't just make up any line out of the sky. Blue had to shoot a line that intersected with one of his bases. So he's shooting this line, but it has to come from a base that is still alive. So now here's what red sees on his paper. He shot this line out of his base A. Do you see that? And then he knows that blue shot this line. So what does red now know? That this has got to be one of these two is the base for blue. And by the way, that's one of the rules. When you choose bases, the students, when they choose bases, the bases have to be at integer coordinates. Oh, crap. I didn't even mean for this. Okay, I didn't even mean for this. Is a lucky shot because look what red just did. Red just killed blue's B base. I didn't even mean that, right? I just made this stuff up out of the sky to demonstrate. But that's the goal of the game. The rule is both players shoot lasers at each other, y equals mx plus b at the same time. The bases have to be at integer coordinates. Red on the left, blue on the right, no one on the axis. But they can't put the base at 3.5, 2.89. No, sir. Okay. But then this has to be an integer or rational number. I don't accept decimals. Same here. So these have to be integers or rational numbers, not fractions, not decimals. I know that a decimal is a rational number, but I really mean when I say fractions, right? Okay. So then the goal is this. So then A, just lucky shot. He just blew up B. And so blue has to say, oh, crap, you destroyed one of my bases or whatever, right? You destroyed base B. You can make it a rule whether or not they say the coordinates that got destroyed. You destroyed base B, which was at 4,5 or whatever it is, right? You can make up whether that's a rule or not. But then blue's like, did I destroy any of your bases? And red says, no, you didn't. So then they're going to play again. And here's what you find out as you play. Because you are shooting from one of your bases, if I shoot from base A again, then this first line and the second line will intersect, and I've just given away where one of my bases is. I've just given away where one of my bases is. Do you see how that works? That's not what a smart player wants to do. A smart player would want to confuse the other player. For example, what if I did this? What if my next one was, I don't know, something like this, where I draw a line that goes through C, but it also goes through this point. Then blue might be like, ooh, there's an intersection there, and then they might shoot at that, but it's an empty space, right? That makes sense. So it's not just practicing y equals mx plus b lines. It's strategy. There's a strategy to playing the game, and if you play the game enough with your students, they're gonna care about y equals mx plus b lines. B, they're going to be thinking outside the box. It's not going to be like your problems are like, okay, I want you to graph y equals 2x minus 1 now. Like, that's an in-the-box problem. There's only one answer, and everybody better get the right answer. Here, they're generating their own problem, and they have a specific goal. Blow up the other guy, right? Exactly. Does that make sense? So there's even strategy involved in where you place your bases. Here, I put my bases at completely random locations, random from the calculator. But as students play, they'll realize, wait a minute, maybe I should cluster my bases together in a certain way, or have one that's over here and have one that's over there. And then I can shoot lines, but then have them intersect in places that are not a base. And then that'll fool the other player into thinking, oh, there's a base there, and there really isn't. And then they waste a shot now, don't they? So this is called Laserblast. If it's something that you think is cool, reach out to me. But I have a whole bunch of math-based games like this. I have a bunch of math-based hands-on activities. So stay tuned in this video, and I'll tell you how you can be a part of that. Well, if you like this activity, I am wondering if you knew this. You can use things like a golf ball to teach ratio, average, linear equations, things all the way up through geometry, piecewise function, parametric equations, all the way up through infinite series and calculus. Do you know that you could use a soda bottle to teach things as simple as functional dependence at the junior high level, all the way up through related rates, all the way through calculus? What if I told you that you could use a pencil, ruler, and coins in order to do things like geometric scaling or the Pythagorean theorem, or linear equations? I forgot to put on here rational functions, right? That you can do ratio and proportional and reciprocal functions and sinusoidal graphs just using a straw and a tuner, or these little pop tubes, right? That you can do quadratic functions and parametric equations with a dart launcher. You can do rational functions and asymptotes, or even teach basic domain and range with a lens and a flashlight, things that you can get at Dollar Tree quite easily. That if you have a water and a thermometer, that you could do exponential decay, that you could teach things as complicated as slope fields and differential equations. These are all things that you can teach at whatever level of math you teach, using basic stuff that you can find or buy just from Dollar Tree or from really cheap places. What about games? What about math-based games where you could go from, basic sixth grade adding up rational numbers to to games where students are shooting y equals mx plus b lines at each other, or they're shooting inequalities at each other, and there's actual strategy to it, right? What about sinusoidal graph wars, that they shoot sinusoidal graphs at each other, or they punch each other out with complex numbers, or they chase each other with the Pythagorean theorem and things like that? Is this stuff that you would want to do in your math class, playing games and doing hands-on stuff? Would you want to do some performance-based assessments, right? I'm not asking you to get rid of your traditional tests, but something that's more open-ended for students, right? What about integrating little writing pieces into your application problems, right? Your word problems, where students have to write a little bit, not just solve the problem. Is that something that you think would be valuable for your students? Is that something cross-curricular that would make you a leader on your campus? What about, would you like to see some methods of remediating tests and quizzes, right? Things where students are getting not only individual feedback, but individual remediation without you having to sit down in front of every single student. Would you like to integrate some basic computer programming in your math course? If any of this is interesting to you, I think that you ought to come to my Summer Institute for Math Teachers. This summer, it's July 15th to the 18th. I teach physics and math. My forte is teaching physics teachers how to make their classes more hands-on and engaging. I've started doing that for math also. Last year was our first Summer Institute. We had 12 participants. They all thought it was pretty neat, the things that they could do with their students. It was much more engaging and fun and things like that. So if you go to findphysics.com, click on Math 2024 Institute, then you'll see the information. Here's some information. It is in person because there's so much hands-on stuff. But we have a discounted rate if you are, the venue is a hotel conference room, so you would get a discount. Your district should be paying for it, obviously, so they would get a discount. We cater lunch every single day, so we provide you with the food. We provide shuttle service to and from the airport, so you don't have to rely on an Uber. You don't have to rent a car if you don't want to. There's lots of dining and entertainment within walking distance. So if this is something that's interesting to you, visit my website. You can contact me through the contact page there, or just look at the Math 2024 Institute. You'll see pictures from last year. You'll see a session agenda and all kind of really cool stuff. And I hope to see you there, because I think that you can really jazz up your math class with some cool hands-on stuff, with some games, and just with some new instructional techniques that make math really interesting and fun to be a part of.